Welcome to The Explainer. Today, we're diving into one of the biggest, most mind-bending mysteries out there. We're going to be cosmic detectives, trying to figure out why is our universe flying apart faster and faster every single day?
All right, so to get our heads around this, let's start with a kind of delicious analogy. Picture this. The entire universe is like a giant loaf of raisin bread dough, and it's rising in the oven. The galaxies? They're the raisins. And as that dough expands, all the raisins get further apart. Now, here's the key thing. The raisins aren't moving through the dough. Nope. The dough itself, the very fabric of space, is stretching, and it's carrying the galaxies along with it.
And that right there, that's the foundational idea. The universe has been expanding ever since the Big Bang, about 13.8 billion years ago. This isn't just a neat idea, it's the absolute bedrock of everything we understand about where the cosmos came from and where it's going. So how did we even figure this out in the first place? Well, our detective story really kicks off back in the 1920s. The main character? An astronomer named Edwin Hubble. He found the first huge piece of evidence. And that clue is something called redshift. You know how when an ambulance drives away from you, the sound of the siren gets lower? That drop in pitch? Well, light does something really similar. When a galaxy is moving away from us, the light it gives off gets stretched out, and that shifts it towards the red part of the spectrum. And what did Hubble see? He saw that the light from pretty much every galaxy out there was redshifted. The conclusion was unavoidable. They were all moving away from us. But it gets even better. Hubble didn't just see them moving away. He found a clear, undeniable pattern. It's now called Hubble's law, and it's super simple. The farther away a galaxy is, the bigger its redshift is. And what does that mean? It means it's moving away from us faster. This was the smoking gun, the proof positive. The universe was, without a doubt, expanding. Okay, so for decades, this was the accepted story. But there was a huge assumption everyone was making about the future of this expansion, and it seemed totally logical. I mean, it just makes sense, right? Think about it. The universe is packed with stuff. Trillions of galaxies, and all that stuff has gravity. So shouldn't all that gravity be acting like a giant brake on the whole thing, pulling everything back together? Everyone figured the expansion had to be slowing down. The only question was, by how much? But then, the plot twist. Fast forward to the late 1990s. You've got two different teams of astronomers, and they're looking at these amazing things called supernova. They're basically exploding stars. The cool thing is, a certain type of these supernova always explodes with the same brightness, which means you can use them like cosmic yardsticks to measure huge distances. So both teams were using them to measure exactly how much the universe was slowing down. Except, that's not what they found. Not at all. They found something that would completely flip our understanding of the universe upside down. Yeah, you heard that right. The expansion isn't slowing down. It's accelerating. It's speeding up. Galaxies are flying apart from each other faster and faster and faster. Imagine tossing your keys up in the air, and instead of them falling back down, they just shoot off into the sky, going faster and faster. It made no sense. It went against everything we thought we knew about gravity.
So this just left this giant, gaping question mark hanging over all of physics. If gravity is supposed to pull everything together, what in the cosmos could possibly be pushing everything apart? And not just pushing, but pushing so hard that it's beating gravity?
Well, scientists have a name for this prime suspect. They call it dark energy. And honestly, mysterious is a pretty good word for it, because we have almost no idea what it is. We can see what it does. It's pushing the universe apart, but we don't know what it's made of. It's like this anti-gravity force that's just part of space itself.
And get this isn't some tiny background effect. No way. To really grasp how much this stuff dominates everything, just look at this number.
Our best estimates tell us that dark energy makes up about 70% of, everything in the universe. Let that sink in. All the stars, all the galaxies, all the planets, you, me, everything, all the normal stuff we can see and touch, that's all crammed into the other 30%. So we're living in a universe that is completely run by something we can't see and don't understand. It's humbling, to say the least. It really is like the ultimate cosmic tug-of-war. You've got gravity over here trying to pull everything together to make clumps and structures. And on the other side, you've got this constant, gentle push from dark energy. And right now, across the whole vast expanse of the universe, It's pretty clear who's winning. The push is absolutely dominating.
Okay, so what does this all mean for us, for the future of the universe? This isn't just some abstract physics problem. The consequences are, well, they're profound and kind of lonely, to be honest. Because space itself is stretching and doing it faster and faster, the most distant galaxies are being flung away from us at absolutely insane speeds. So fast, in fact, that they'll eventually be moving away from us faster than the speed of light. Now hold on, I know what you're thinking. Nothing can go faster than light. And you're right, nothing can travel through space that fast. But space itself can expand that fast. And when it does, it creates this invisible boundary, a point of no return called the cosmic horizon.
So here's how it plays out over billions of years. Right now, today, we can look up and see the light from galaxies that's been traveling for eons to reach us. But way out in the distant future, the farthest of those galaxies will cross that cosmic horizon. And from that moment on, any light they send out will never get to us. The space between us will be expanding too fast for the light to ever catch up. One by one, they will literally vanish from our sky. Just gone from our view, forever.
What this all really drives home is that we live in a universe that is anything but static. It's not just some fixed backdrop. It's this vast, dynamic, expanding stage. And the story that's unfolding on that stage right now, it's a story of acceleration and of things getting farther and farther apart. And that just leaves us with one last, truly mind-bending question to chew on. If the whole universe, all of space, all of time, is getting bigger, what is it expanding into? And the weird, tricky answer is nothing. It isn't expanding into some empty void. The expansion of the universe is actually creating more space as it goes. Something to think about the next time you look up at the night sky. A sky that's getting bigger, faster, and ultimately emptier every single moment.